Good morning. We're going to look at how to solve differential equations this chapter. And different methods to do that. And the first way is to do this using like calculus and finding an exact solution. And then we're going to have some estimations. So today we're going to go ahead and split apart our differential equations and solve for a solution. So a differential equation is one that has a derivative in it, okay? Some examples, population growth, sales, anything that is like exponential growth, Newton's law of cooling, radioactive decay, okay? So the way we solve a differential equation is, the solutions to a differential equation, we have a general solution where we use a C value, okay, some unknown C value that we have to solve for. What I mean about a solution to a differential equation is basically when you have an equation that you can plug into your differential equation, which remember has a derivative in it, and then it balances the equation. So here's what I mean. I have my solution, y is equal to e to the negative x, and this is my differential equation because it has a derivative in it. So for my solution, I notice that I'm going to plug it in for y, but I also need to get the derivative. So the solution is y is equal to e to the negative 2x because that satisfies my differential equation. Let's see. Okay, so I'm going to take the derivative of y, which is negative 2e to the negative 2x. And then for my differential equation, let's just make sure it balances. This is like algebra where you like plug it in, make sure it balances, is all good. All right, so we get the differential equation is y prime plus 2y is equal to 0. All right, and then I notice that negative 2e to the negative x is equal to y prime plus 2, and then y is equal to e to the negative 2x is equal to 0. What do you know? 0 is equal to 0. So one solution to the differential equation is this y is equal to negative e to the negative 2x. Okay? All right, so a general solution would be like if we didn't have a C value, so just we have some arbitrary constant, this will still work. So if I have my general solution and my differential equation is the same, y prime plus 2y is equal to 0. So I'm just going to write y prime is equal to, I would multiply c times the negative 2, so negative 2c, e to the negative 2x. And so I'm going to go ahead and plug that in. Negative 2c e to the negative 2x plus 2 times c e to the negative 2x is equal to 0 because that's what y is equal to. So I notice again, I get 0 is equal to 0. So this equation c times e to the negative 2x satisfies my differential equation. The way we would find our c value is like normal. You plug in an initial value or initial point to find that value. Okay, so the steps to solve, what we're going to do is we're going to rewrite y prime as dy dx, and then I split the dy and dx onto two different sides. Okay, then I move the variables x and y to go with the sides of dy dx. Okay, I add c to one side, and then in here I'm going to be really careful to start labeling my c's as c1, c2, c3 as they change calculation. And then steps 5 and 6 are interchangeable. Sometimes you need to solve for y, and then sometimes if you're given an initial condition, you're going to have to solve for c. Okay, so you can switch those at any point. All right, so number 1, solve the differential equation y prime is equal to 2x over y. So according to step 1, we're going to rewrite my y prime as dy dx is equal to 2x over y. Okay, then we're going to multiply both sides by dx to get rid of the dx on one side. So I get dy is equal to 2xy times dx. All right, then I'm going to multiply y on both sides to get rid of y. So I get y dy is equal to 2x times dx. All right, so this is what I call separate and integrate. So we separated the dy dx and our x and our y's. So now we're going to integrate. Okay, so the derivative or the antiderivative of y is 1/2 y squared, and that's equal to 1/2 times 2 x squared plus c1. All right, now we need to get y by itself. So I'm going to go ahead and multiply both sides by 2. So I get y squared is equal to, that's 1, so that's 2x squared plus c2. And so c2 is really equal to 2 times c1. Okay. All right, so now we're just going to get y by itself, so we take the square root. So I get plus or minus the square root of 2x squared plus c2. And that's that. Okay, up next, we're going to go ahead and do the same thing, but with x squared plus 4 dy dx is equal to x times y. So it's time to separate and integrate. I'm going to move, I'll just rewrite it, x squared plus 4 dy dx is equal to xy. Multiply dx on both sides, so we get x squared plus 4 dy is equal to x times y times dx. I'm going to divide both sides by y, and I get x squared plus 4 over y is equal to times dy is equal to x dx, and then I'm going to divide both sides by x squared plus 4 to move it. Okay, you can do that in one step if you wanted. Okay, so I get 1 over y dy is equal to x over x squared plus 4 dx. Okay, now we integrate to get, well, before I integrate the left side, I'm going to make a u substitution. So I get u is equal to x squared plus 4. So du is equal to 2x dx. So I get 1 over y dy is equal to the integral of x over u. And then dx is equal to du over 2x. Okay. So x over u times du over 2x, right? Yeah, okay. See, my x's cancel. I get 1 over y dy is equal to the integral of 1/2 times the integral of 1 over u du. All right. So the integral of 1 over y is ln times the absolute value of y is equal to, same thing on this side, but with u, so 1/2 ln absolute value of u plus c1. Time to replace my u. Okay, my u was x squared plus 4. So the absolute value of x squared plus 4 plus c1. All right, using the power rule, I'm going to move the 1/2 to be the power of the input. And also I noticed that X squared plus 4 is always positive, so I can go ahead and drop the absolute value signs. So I have the ln of the absolute value of y is equal to the ln of the x squared plus 4 to the 1/2, which is the square root of x squared plus 4, plus c1 is on the outside. All right, up next, you can snail, or you can raise, to get rid of the ln, we can raise both sides to the e. So e to the ln of y equals e to the ln of the square root of x squared plus 4. When you raise e to the ln, it cancels itself out. So I get the absolute value of y is equal to the square root of x squared plus 4 plus, oh wait, this is e to the ln of the absolute value of x squared plus 4 times e to the c1. Remember, when you add exponents, you are really multiplying the bases. So, in fact, I should just write that here. Okay, so this is e to the ln absolute value of y is equal to e to the ln of the square root of x squared plus 4 times e to the c1. Okay, the adding the exponent multiplies the bases. So I get the absolute value of y, because the e's and the ln's will cancel, okay, equals the square root of x squared plus 4 times e to the c1. We can just call that c2 because it's a constant. This is a constant. Okay, so our next step is to isolate, just keep isolating. Yeah. Okay, so I want to drop the absolute value sign. So remember, if you drop the absolute value signs, what you end up with is a plus or a minus. So I get a plus or minus c2 times the square root of x squared plus 4. And actually, the plus or minus doesn't matter. Doesn't matter because c2 is a constant. And the sign will present itself when we solve using the initial condition. And solve using the initial condition, or the start. The plus or minus will present itself. So it'll either come out, depending on the initial condition, the C2 will either come out plus or minus. So what we're going to do is just change our C2 to a C3, saying that we're absorbing the plus or the minus, and we're done. All right, next one. We're going to do the same thing, but these last two we solve for the general equation because we left in our C value. Okay. The next two we're going to solve for a specific, or a specific solution, and using our initial condition. So our initial condition is y of 0 is equal to 1, and our differential equation is xy dx plus e to the negative x squared times y squared minus 1 dy is equal to 0. So I'm just going to rewrite that. Xy dx plus e to the negative x squared times y squared minus 1 dy is equal to 0. All right, time to separate and integrate. Here we go. So I'm going to move this whole dx to the other side. Okay, so I get e to the negative x squared times y minus 1 dy is equal to negative x y dy. Okay, next we're going to move around the x's and the y's. So I'm going to divide both sides by y. And I'm going to divide both sides by e to the negative x squared. So we get y minus 1 over y dy is equal to negative x over e to the negative x squared dx. I see a dy. This should be a dx. Okay. So now we can integrate, but I'm going to rewrite this a little nicer. Y minus 1 over y dy is equal to negative x times e to the x squared because of negative exponents dx. Integrate time. Okay. My thought on the left is that since I have a monomial, I can divide into both terms in the numerator. So I get that 1 minus 1 over y dy is equal to, and then on the right, I'm going to use a u substitution. So u is equal to, I'm going to make my exponent my u. So I get du is equal to 2x dx, and dx is equal to du over 2x. All right, let's see what happens. I get negative x times e to the u times du over 2x. X's cancel. Go ahead and rewrite 1 minus 1 over y dy is equal to the integral of, let's see, I'm going to put the negative 1/2 on the outside, e to the u du. All right, time to integrate for real. All right, so the integral of 1 is, I made a mistake, and this, I forgot the squared. So I'm going to put the squared right here. And I'm going to put the squared right here. And I put the squared right here. And then so y squared divided by y would be y minus 1 over y. Y minus 1 over y. Okay. Everything else I think is okay. Good thing I checked my work. Okay. Up next. The integral of y is 1/2 y squared minus 1 over y is the ln of the absolute value of y. And that's equal to negative 1/2 e to the u plus c1. All right, replace u with 2x, I think. X squared. X squared plus c1. All right. Now I'm going to go ahead and skip since we have an initial condition. Remember, our initial condition is y of 0 is equal to 1. I'm going to skip to step 6, which is to plug in and to solve for c. Y sub 0 is equal to 1. All right, so anywhere there is an x, I'm going to plug in 0, and anywhere there's a y, I'm going to plug in 1. So I get 1/2 times 1 squared minus the ln of 1 is equal to negative 1/2 e to the 0 plus c1. And I know that ln 1 of 1 is equal to 0, and e to the 0 is equal to 1. So I get 1/2 is equal to negative 1/2 plus c1. Add 1/2 to both sides. I get 1 is equal to c1. So I can go ahead and write my differential equation, the solution to my differential equation as 1/2 y squared minus the ln of the absolute value of y is equal to negative 1/2 e to the x squared plus 1. I am not going to solve this one for y because it is very complicated. Okay. We're going to stop there. That's it. One more example. All right, so we're going to find the particular solution that goes through the point 1, 3 and has a slope of y over x squared at the point x comma y. So slope, y'all, remember slope, derivative, dy dx. So I can go ahead and just write this. Dy dx is equal to y squared over y over x squared. Okay, so it's time to separate and integrate. I get, okay, dy is equal to y over x squared dx. If you can do this in one step, that's fine. Divide both sides by y, so I get 1 over y dy is equal to 1 over x squared dx. Or 1 over y dy is equal to x to the negative 2 dx. Okay, we can go ahead and just integrate. So I get ln of the absolute value of y is equal to negative x to the negative 1 plus c1. Okay, so you get a choice now. You can either switch to step 5 or to step 6 and plug in the 0.1 comma 3. I'm going to just go in order this time and plug in and start with step 5, which is to isolate y. It's up to you. All right, so we get the ln of y is equal to, I'm just going to rewrite this. The ln of y is equal to the ln of the absolute value of y. We can't drop the absolute values because y could be positive or negative. And then I get negative x, negative 1 over x plus c1. And then what I'm going to do is either snail or put the base of e on both sides. My e's will e and the ln will cancel here, just leaving the absolute value of y. But then I'm going to rewrite on the right e to the negative 1 over x times e to the c1. Remember, if you're adding your exponent, you are multiplying the bases. So then I end up with the absolute value of y is equal to e to the c1 is a constant, so I'm going to call that c2. c2 times e to the negative 1 over x. And then I need to plug in my initial value. Okay, so I get 3 is equal to c2 e to the negative 1, because negative 1 over 1. And then we're just going to solve for c2. So we get 3 over e to the negative 1 is equal to c2. Or in other words, c2 is equal to 3e. Okay, so last step is to just plug this in. So I get the absolute value of y is equal to, I'm just going to write y is equal to, because again, the plus or minus will get absorbed in the c. So we end up with 3 c2 e to the negative 1 over x. So 3e is c2 times e to the negative 1 over x. And then e in the c, e has a power of 1. So this would be y is equal to 3 times e to the negative 1 over x plus 1. I can add the exponents. And that's it.